So we're going back to the simulation we looked at yesterday. Remember, this is a combination of an aerial and a cross-section view. You can see the aerial, the top section, the green, and you can also see the side view. This is almost like a three-dimensional model, but we have a cross-section to the side here. And although I didn't mention it yesterday, the convection currents cells were already in the model. You can see those yellow arrows down below. Those are going to be the convection cycle arrows that we've seen where we're rising up or we're moving off to the side. And it is those convection cycles that are moving the plates. As we said yesterday, that the plates can move in three directions in relationship to one another. Today we're going to look at only two of those. The first type of plate motion we're going to talk about is something called divergent. To diverge means to move apart. So when we think about divergent plates, the plates are moving away from each other. As you watch this model, you should watch to see how convection in the mantle is pushing the crust in two directions away from each other. As this happens, earthquakes are occurring. We saw that yesterday. Also, you should notice that the time frame that we're using is massive. We're talking millions and millions of years, in this case, 5 million years. That means that this process is extremely slow in real life, and we are speeding it up. Okay, so I'm going to run through this. We're going to watch what happens. You can see the convection currents moving slowly underneath, and you can see that the two pieces of the plate are pushing off to either side. You have the earthquakes in the middle, those concentric circles, and we're pushing off to the side. I'm going to reset this. We're going to do it again. Same thing, 5 million years. We're going to watch it one more time. We're going to see the convection cycles pushing off to the two sides. We're seeing the plate being pushed off to either side. It looks like it's almost growing off to either side. And then down the middle, we have those earthquakes that are occurring, and we're going to talk more about that later. Now, the second way that plates can move in relationship to one another is toward one another. We call this type of motion convergent. To converge means to move together. You should notice that there are still earthquakes happening as we do this. So I'm going to put these guys together. We're going to see the plates over time. We're going to pick again 5 million years. And you'll notice this time that the convection currents seem to be moving in a slightly different direction. We're pushing in this direction. We were getting this getting cooler, more dense. It's falling down, moving across, getting cooler, more dense, falling down below. So we're going to watch this run. We're going to see what happens. We're going to see that this time the plates, you can see them, they are squeezing together. And some things are happening. We've got some earthquakes going on, some other things that are beginning over in the middle. We're going to talk more about that another day. But you do see these convection currents. We're going to try that one more time. 5 million years, we're going to watch the convection currents run. And we again should see that the plate is moving together because the convection currents are pushing them together from underneath. Your video code for this video is 1123 1123.